galaxy of Warwick, the solar system could be thrown into destruction when the Sun dies if the mysterious planet X exists. In Warwick Department of Physics, Dr. Dimitri Vera found that the presence of Planet X, the hypothetical planet which may exist in the outer solar system, could eliminate at least one of the giant planets after the Sun dies, hurling them out into interstellar space through a kind of fireball effect. When the Sun begins to die, it will blow away half of its own mass and increase itself, taking over the Earth, before fading into an ember known as a white dwarf. This mass ejection will push Jupiter, Saturn, Uranus and Neptune out to what was known as safe distance. Although, Dr. Vera has found that the existence of Planet X could rewrite this happy ending. He found that Planet X might not be pushed out in the same manner, and in fact might instead be thrust inward into a death dance with the solar system's four known giant planets, most notably Neptune and Uranus. The most likely result is ejection from the solar system, forever. Using a different code that can simulate the death of planetary systems, Dr. Vera mapped out numerous different positions where Planet X could change the fate of the solar system. The more massive the planet is, the higher the chance that the solar system will experience a violent future. This discovery could unveil planetary architectures in different solar systems. Nearly half of existing white dwarfs contain rock, a potential signature of the debris created from a similarly calamitous fate in other systems with distant planet axes of their own. In effect, in the future not so long from now, death of our Sun could explain the evolution of other planetary systems. Dr. Vera highlights the danger that Planet X could create. The existence of a distant massive planet could change the fate of the solar system. Neptune and Uranus in particular may no longer be safe from the death throes of the Sun. The fate of the solar system would depend upon the orbital and mass properties of Planet X. The future of the Sun may be foreshadowed by white dwarfs that are destroyed by rocky debris. Planet 9 could be a catalyst for the destruction. The Sun's future identity as a white dwarf that could be destroyed by rocky debris, perhaps, reflect current studies of other white dwarfs throughout the Milky Way, Dr. Vera confirms. In the race to discover a proposed ninth planet in our solar system, Carnegie's Scott Shepard and Chadwick Trujillo of Northern Arizona University found several never-seen-before objects at extreme distances from the Sun in the solar system. To the International Astronomical Union's Minor Planet Center for official designations, Shepard and Trujillo have submitted their latest findings. A paper about the findings has also been submitted to the Astronomical Journal. The more objects that are found at extreme distances, the better the chance of constraining the location of the Planet X that Shepard and Trujillo first claimed to exist far beyond Pluto, itself no longer classified as a planet, in 2014. The orbits and placement of small, so said extreme trans-Neptunian objects, can help narrow down the size and distance from the Sun of the Planet X, because that planet's gravity changes the movements of the smaller objects that are far above Neptune. The objects are known as trans-Neptunian because their orbits around the Sun are bigger than Neptune's. In 2014, Shepard and Trujillo announced the discovery of 2012 VP-113, nicknamed Biden, which has the most distant known orbit in our solar system. At this time, Shepard and Trujillo also noticed that the handful of known extreme trans-Neptunian objects all cluster with similar orbital angles. This led them to predict that there is a planet at more than 200 times our distance from the Sun. Its mass, ranging in possibility from several Earths to a Neptune equivalent, is shepherding these smaller objects into similar types of orbits. Some have called this Planet X or Planet 9. Further work since 2014 showed that this massive ninth planet likely exists by further constraining its possible properties. Analysis of neighboring small body orbits suggests that it is several times more massive than Earth, possibly as much as 15 times more so, and at the closest point of its extremely stretched, oblong orbit it is at least 200 times farther away from the Sun than Earth. This is over 5 times more distant than Pluto. Objects found far beyond Neptune hold the key to unlocking our solar system's origins and evolution, Shepard explained. Though we believe there are thousands of these small objects, we haven't found very many of them yet, because they are so far away. The smaller objects can lead us to the much bigger planet we think exists out there. The more we discover, the better we will be able to understand what is going on in the outer solar system. Shepard and Trujillo, along with David Thalin of the University of Hawaii, are conducting the largest, deepest survey for objects beyond Neptune and the Kuiper Belt and have covered nearly 10% of the sky to date using some of the largest and most advanced telescopes and cameras in the world, such as the Dark Energy camera on the NOAA 4-meter Blanco telescope in Chile and the Japanese Hyper-Suprime camera on the 8-meter Subaru telescope in Hawaii. As they find and confirm extremely distant objects, they analyze whether their discoveries fit into the larger theories about how interactions with a massive distant planet could have shaped the outer solar system. Right now we are dealing with very low number statistics, so we don't really understand what is happening in the outer solar system, Shepard said. Greater numbers of extreme trans-Neptunian objects must be found to fully determine the structure of our outer solar system. According to Shepard, we are now in a similar situation as in the mid-19th century when Alexis Bouvard noticed Uranus' orbital motion was peculiar, which eventually led to the discovery of Neptune. The new objects they have submitted to the Minor Planet Center for designation include 2014 SR 349, which adds to the class of the rare extreme trans-Neptunian objects. It exhibits similar orbital characteristics to the previously known extreme bodies whose positions and movements led Shepard and Trujillo to initially propose the influence of Planet X. Another new extreme object they found, 2013 FT28, has some characteristics similar to the other extreme objects but also some differences. The orbit of an object is defined by 6 parameters. The clustering of several of these parameters is the main argument for a 9th planet to exist in the outer solar system. 2013 FT28 shows similar clustering in some of these parameters: its semi-major axis, eccentricity, inclination, and argument of perihelion angle, for angle enthusiasts out there. But one of these parameters, an angle called the longitude of perihelion, is different from that of the other extreme objects, which makes that particular clustering trend less strong. Another discovery, 2014 FE72, is the first distant Oort cloud object found with an orbit entirely beyond Neptune. It has an orbit that takes the object so far away from the Sun, some 3,000 times farther than Earth, that it is likely being influenced by forces of gravity from beyond our solar system such as other stars and the galactic tide. It is the first object observed at such a large distance.
Seek